In today's session, we shall concentrate on convolution sum between two finite duration signals. So consider this example where Hn is equal to alpha raised to n u of n minus u of n minus 5 and Xn is equal to u of n minus u of n minus 7. Now both these are finite duration and their length is limited. So it is essential first to sketch this Xn and Hn. Now Xn is u of n minus u of n minus 7. So what are the amplitude of Xn and from where to where it exists when u of n is from u of n, when you subtract u of n minus 7, how much amplitude you get and from where to where this Xn exists. Sketch this Xn. Okay. So what is your sketch? See, Xn exists from 0 to 6 with amplitude 1 and that of Hn exists from 0 to 4 with amplitude alpha raised to n. Now what is left end of Yn? Left end of Yn is 0 and the right end is 10 here. Because the right end of Xn is 6 and that of Hn is 4. So right end of Yn is 10. Now resketch this Xn as Xk and Hn as Hk and reflect about origin h of k and write h of minus k so that we'll get this to sketch here. So this is x of k and this is h of minus k. Now if I shift left this h of minus k for n which is less than 0, you will observe that there will be no overlapping between the shifted h of minus k and xk. And therefore the product xk and h of n minus k will be equal to 0. So yn definitely will be equal to 0 for n which is less than or equal to 0. Here for n is equal to 0, the product exists from 0 to 0. Now there is no point in shifting left this h of minus k. So we shall shift this to right. Now see the possibilities here. Both are the finite duration signals and the width of xk is a 6 unit. This is not an exact sketch with the amplitudes. This box represents its width is 6. For 6 time duration this xk is exists. And this h of minus k exists for 4 unit. And you observe that when k is equal to 0, this is existing from 0 to minus 4. That is when n is equal to 0. It is existing from k is equal to 0 to minus 4. So if I say this is as h of n minus k, so this end of this h of n minus k is n and this end is n minus 4. So for k is equal to 0 right now, not k is equal to 0, n is equal to 0. Right now this n will be equal to 0 and this n is 0. That means it is existing from 0 minus 4 to 0 here. This is the position of h of n minus k at n is equal to 0. Now if we go on shifting this to the right side, this will move like this towards the right side and you observe that this xk and h of n minus k, these two overlap. How they overlap? They always overlap for the duration from 0 up to n and the product will exist from 0 to n. So h of minus k I am shifting to this side, right side. So I have taken here h of minus k. So after shifting it will become h of n minus k. This is just this block I am moving it for just understanding purpose. Now since the width of this block is smaller, so when you shift this 4 times, that is 4 units, what will happen is, see it will happen like this. If for n is equal to 4, you will get here this n minus 4 here at 0 and this n here at 4. And this entire block overlaps with xk. Now the overlapping still is from 0 to n, but the entire block overlaps. Now this entire block of h of n minus k overlap till what? till I go on shifting it up to this unit. That is up to n is equal to 6 if I go on shifting this h of minus k towards this side. So up to n is equal to 6, this entire block of h of n minus k overlap with this xk. Now in this duration, that is from 4 to 6, this entire block overlaps, and that time overlapping is from this end to this end, that is from n minus 4 to n. In between 0 to 4, the overlap is from 0 to n, and then from 4 to 6 it is from n minus 4 to n. Now onwards, if I shift this to this side, what will happen? Part of this h of minus k will overlap with this xk, and you will observe that the overlapping always will be from n minus 4 up to 6. So how much duration this go on shifting? If you go on shifting this to this side, it is until we get this end here at 6. So when this get end n minus 4 end we get at 6 when n is equal to 10 here. So 10 minus 4 becomes 6, and you will get this here. So until this, you will observe that the overlap will be always from n minus 4 to 6. After 10, if you shift, there will be no overlapping between this xk and this h of n minus k, and again yn will be equal to 0. So our observation here that there are three possibilities of regions where xk and h of n minus k overlap and the product exists. The one region is from n which is varying from 0 to 4. So n which is greater than or equal to 0 and less than 4. At that time, these two overlap from 0 to n. Then the other region for n which is greater than or equal to 4 and less than equal to 6 and overlap from n minus 4 to n. And the last region where they overlap is from n which is greater than 6 and less than equal to 10. The overlap is from n minus 4 to 6. So in this duration, writing the product of this xk and this h of n minus k. So the first region, let me write this as where k is in between 0 to 4, yn is equal to summation k from 0 to n alpha raised to n minus k. Xk's amplitude is 1. So this is alpha raised to n minus k. Alpha raised to n you take outside, and the closed form of expression for this alpha raised to minus k, you will get it as 1 minus alpha raised to minus n minus 1 upon 1 minus alpha inverse. Now when you multiply inside with this alpha raised to n to this, it is alpha raised to n minus alpha inverse upon 1 minus alpha inverse. Multiplying both numerator and denominator by another alpha, you will observe that it is alpha raised to n plus 1 minus 1 upon alpha minus 1. This is in the region where k is varying from 0 to 4. Now in the next region where n is varying from 4 to 6, you observe that the overlap is from n minus 4 to n, and the product is still alpha raised to n minus k, and the closed form of expression for k varying from n minus 4 to n alpha raised to minus k. So the closed form of expression is alpha raised to n into alpha raised to minus n minus 4 minus alpha raised to minus n minus 1 upon 1 minus alpha inverse. Now multiplying here a numerator with alpha raised to n, you will observe here this is alpha raised to 4 minus alpha inverse upon 1 minus alpha inverse, which is equal to alpha raised to 3 minus 1 upon alpha minus 1. This is where n is varying from 4 to 6. Now for 6 onwards and up to 10, you will observe that the overlap is always from n minus 4 to 6. The product is still alpha raised to n minus k, and this we have to obtain the closed form expression from n minus 4 to 6 for this alpha raised to minus k. So this closed form of expression is alpha raised to minus n minus 4 minus alpha raised to minus 7 upon 1 minus alpha inverse. Now multiplying here inside numerator with alpha raised to n, you will get here alpha raised to 4 minus alpha raised to n minus 1 upon 1 minus alpha inverse. I am multiplying both with alpha numerator and denominator, you will get alpha raised to 3 minus alpha raised to n minus 6 upon alpha minus 1. It's yn. So summarizing the output, you will get yn is equal to 0 for n less than 0. It is alpha raised to n plus 1 minus 1 upon alpha minus 1 for n varying from 0 to 4. And it is alpha raised to 3 minus 1 upon alpha minus 1 for n varying from 4 to 6. And then it is alpha raised to 3 minus alpha raised to n minus 6 upon alpha minus 1 for n varying from 6 to 10. And it's 0 again for n greater than 10. This is the second example here where we need to convolve xn and hn, where length of xn is a finite duration and it is defined in terms of impulses, shifted impulses. This is delta of n plus 1 minus delta of n minus 1 plus delta of n minus 3, and hn is delta of n minus delta of n minus 2. So to solve this convolution, we will not use the graphical method, whereas we will use the property of distribution and this convolution of a signal with impulse response. So any signal x of n, when you convolve it with the impulse response delta of n, you know that the convolution between it is x of n itself. So what we do is y of n, where it is x of n convolved with hn, and xn is this and hn is this. That is, xn is delta of n plus 1 minus delta of n minus 1 plus delta of n minus 3. I will convolve it with delta of n minus delta of n minus 2. Now using the distribution property, first this x of n I convolve with delta of n, and then this x of n will convolve with this delta of n minus 2. So that is minus xn convolved with delta of n minus 2. So when you convolve this xn with delta of n, you get x of n itself. And when you convolve this xn with delta of n minus 2, you will get x of n minus 2. So writing that yn is equal to, so this xn convolved with delta of n minus this xn with convolution with delta of n minus 2. So when you convolve with delta of n, you get x of n itself, that is delta of n plus 1 minus delta of n minus 1 plus delta of n minus 3. And when you convolve this xn with delta of n minus 2, you will get x of n minus 2. So x of n minus 2 therefore will be equal to minus of this x of n minus 2. So this minus to x of n minus 2, so every n is to be replaced with n minus 2. So in this way, wherever you have n, if you replace with n minus 2, what you get? So this term minus delta of n plus 1 becomes minus of delta of n minus 1, and this, when you replace it with n minus 2, this becomes n minus 3. So this minus and this minus is plus, so you will get plus delta of n minus 3, and this minus and plus minus delta of n minus 3, and n replaced by n minus 2, minus 2 and minus 3 minus 5, so minus delta of n minus 5. Combining together all the terms together here, you will get yn equal to delta of n plus 1 minus 2 delta of n minus 1 plus 2 delta of n minus 3 minus delta of n minus 5. So thank you very much, dear students, for your patient hearing. So we shall stop here.